All right, welcome back. Now we're going to do an example. Here's the equation that they give us. Okay, we can see that it's an equation of a hyperbola. Okay, and the first thing they want us to do is graph it. Okay, so first we notice that this is centered at the origin, right? It has the form. Also notice that the positive, the x value has the positive coefficient, right? So here it's a subtraction, so x is here, y is here. So this tells us that this is going to traverse the x-axis, right? So the graph of the hyperbola is going to cross. It's going to cross the x-axis. Okay. So now we know the center is at the origin. We need to know where the vertices are. Okay. Now, and that's going to be our a value, right? So we got to find our vertices, and we got to find our draw the box, right? So in this case here, remember A is always under the first one. So it's always A squared, right? So that's one thing you have to remember about hyperbola, is that this is A squared, this is B squared. These are going to change, okay? This is always A squared, this is always B squared. Now remember with the ellipse, we always said, hey, the A squared, right, the major axis is always the larger value, right? So that's a little different here, okay? So we're looking at here is A squared is here. So since x is here before the subtraction, it has the positive coefficient, it means that the hyperbola is going to traverse the x-axis, and this is A squared, right? So A squared equals 4, B squared equals 9, which means that A is equal to 2 and B is equal to 3. Okay, so that means our vertex is going to be located at what? 2, 0 and negative 2, 0. Okay, so now we know it's going to be at here and here, right, are the vertices. Okay, so we got those. And then B is going to help us with the rectangle. So that's going to be here. So B is going to be along the y-axis. So it's going to be centered at the origin, right? The box is going to be centered at the origin. And it's going to be the vertices and the B, right? The B values that are going to make the box. So that means this is going to go like this. Right? So there's our box. There's our reference rectangle. Okay? Now the other thing too is remember that the asymptotes, remember the equations of the asymptotes are going to be y over what? B minus, in this case it's going to be B over A. X and y equals negative B over A. Okay? So 3 over 2. So if we go up 3, 2, boom. 3, 2, boom. So remember, it always goes through the corners of the box. So if we draw the asymptote, so let's do this. Like so. So there's 1. And then let's do the other one. Like so. So there are the asymptotes. Notice they go through the corners of the box, the reference rectangle. Okay? And now what we're going to do is sketch the graph. So we start at the vertex and we curve, right, towards the asymptotes, right? So again, it doesn't have to be perfect, right? Just like that. And so there's the graph of the hyperbola. Now the other thing too is they want us to identify the center. So the center here is at the origin, 0, 0. The vertices, we already said the vertices. The vertices are going to be 2, 0 and -2, 0. Those are the vertices. Okay. The foci, well, the foci is at C. So let's find out what C is, right? So remember, B squared is C squared minus A squared, right? By definition. So that means C squared is B squared plus A squared. And so that's going to be what? 4 plus 9, which equals 13. So C is the square root of 13. Okay? So that means our foci is going to be located at what? Square root of 13, 0, and also negative square root of 13, 0. Okay, and then the equation of the equation of the asymptotes are right there. Okay, notice it's, oh, we didn't put the x, and they want us the equation, so let's put in for the b and the a, right? So to make it official, so it's going to be 3/2 x and -3/2 x. Those are the equations of the two asymptotes. All right, that's it. It's that easy to graph and to identify the important aspects and characteristics of a hyperbola. Just practice.